All right, so we're going to talk about determining reference angles. We're going to use some of the skills from the coterminal angles to help us figure out the reference angles. Because again, I think this is where we're kind of struggling a little bit. We're not getting 100% on these types of questions, and I want to help you get 100% on that. So let's say we have 840 degrees. All right. So based off the last video, I need to figure out where this angle would be somewhere between 0 and 360 degrees. So that means I'm looking for a coterminal angle between 0 and 360. And I know that's going to yield 120. You can pause the video, work it out yourselves just to verify how I got my answer if you need to. All right. So if I draw this out, I know that this angle will look something like this. It's going to start here at the 0 degrees and it's going to rotate 120 degrees. So that's the 120. To get the reference angle, I'm just looking to see how far off the closest x-axis is this angle. So I know that this angle, the closest x-axis, is right here in the purple. And this is the 180 degree mark. So if I'm at 120 and you need to get to 180, well, I can just say that's going to be 60 degrees. So this angle has a reference angle of 60 degrees. And that's all you have to do. Take the given angle. If it's not already between 0 and 360 degrees, make it so, right? Find that coterminal angle within that interval. Once you have it in the interval, just give yourself a little sketch, either mentally or actually draw it out. You guys have Zeitboard accounts. And figure out how many degrees off the closest x-axis is this angle. And that's pretty much it for the degrees. But we're going to talk about the radians, because the radians are the ones where they have some patterns. And I'll show you some of the patterns that I use, which made sense for me. If you guys have your own patterns, I would love to see what you guys come up with, because I'm always looking for different ways to help explain stuff to you in a way that makes sense. So we're going to start off by drawing our coordinate grid. All right. And let's say that we have, actually, let's start with talking about the 5 reference angles, and then we'll talk about some patterns that you may notice. So you have 0, which would be in radians, right? Because now we're going to focus on the radians. So if we're talking about 0, well, 0 would be this right here, which is 0 degrees off, or 0 radians off the x-axis. So that means that angles that would have a reference angle of 0 radians would also have to be on the x-axis. So you could have 0, you could also have pi, we could also have 2 pi, we could also have 3 pi, and we could have 4 pi. And hopefully you guys are trying to pick up on what I'm laying down. If you have an integer value, so it could be positive, it could be negative, but as long as it's an integer multiplying by a pi, it will have a reference angle of 0. That's it. Pretty easy. So now let's talk about the next one that would come up would be pi over 6. So let's start with the pi over 6. All right. Again, start this off, I need to get my grid on, coordinate plane on. Okay, so if we are talking about the x-axis, or pi over 6, I should say, sorry. I was trying to make sure that it was in freehand mode so I could draw and not just have lines. Well, pi over 6 is this much off. So if I mirror it, it should be this much off. If I mirror it, it should be this much off. If I mirror it, it should be this much off. Right? So between 0 and 2 pi, angles that would have a reference angle of pi over 6 would be 5 pi over 6. It would be 7 pi over 6. And it should be 11 pi over 6. Okay. So remember how we started with the 0 degree? I'm sorry, with the 0 radians. I need to be careful. We're talking about radians. So the 0 radians. They were 0, pi, 2 pi, 3 pi, 4 pi, etc. pi's, right? The reference angle is telling me how far off the x-axis these angles are, and all these angles are pi over 6 radians off of the x-axis. So, if you notice, right here, if you look at the numerator, all these numerators are 1 away, give or take, from getting to a whole number pi, right? So, 5 pi over 6, if you tack on that pi over 6, right, this little bit right here in the purple, that would get you to 6 pi over 6. So that would be pi. Okay, so that means that's how far off the x-axis it is. So if I do the same thing with 7 pi over 6, this one, it's a little over the x-axis, right? It went past, if I'm talking about the rotation, goes all the way like this. So I would have to take away a pi over 6, which would get me 6 over 6 again, or 6 pi over 6, which again just reduces down to pi. So that's it. So that's what the reference angles are between 0 and 2 pi. But if I'm talking about angles past the 0 and 2 pi, like outside that interval, well, I just need to add a rotation. So if I add a rotation, aka a rotation would be 2 pi. So if I'm talking about a rotation for pi in terms of pi over 6, that 2 pi becomes 12 pi over 6. Okay? So, give or take pi over 6, or 12 pi over 6. To each of these should give you a reference angle of pi over 6. And if you don't believe me or you aren't sure, try it out. Take the angles, add or subtract to 12 pi over 6. If you get one of these 4 in the red, you have a reference angle of pi over 6. Another way you can think about it is this. Let's say I gave you, what's a nice number? 35 pi over 6. Okay. And I want to see if it's going to be a reference angle of pi over 6. So here's what I'm going to do. I'm going to look at the fraction right here. The pi is just to let me know that it's going to be in radians right now. And 35 over 6 is 5 and 5, 6. Because it has the pi still from over here, well, I see the 5 pi over 6, I see the 5 pi over 6, I'm done. It's a reference. like it has a reference angle of pi over 6. That's all I need to do. The 5 right here is just telling me, well, it's going to be close to the 5 pi on the x-axis, right? So I can kind of ignore that part. I'm really looking at the fraction, be it improper or not, to go from there. That's it. So that was for the pi over 6. If I'm talking about the 4 pi over 6, I would argue it's easier than the pi over 6. And hopefully you'll see why. And again, if you guys have a different way of viewing this, I am all ears right now. Because I want to make sure you guys see it and you guys understand it, because when you guys take a higher level math, this trig is not going to get like... You just really need to know this off the top of your head to make life easier for you moving forward. So, if I'm talking about pi over 4, well, it could also be 3 pi over 4. It could be 5 pi over 4. It could be 7 pi over 4, right? Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Look at your numerator, right? Technically, the pi over 4 has... It's a 1 pi over 4. 1, 3, 5, 7. As long as you have a denominator of 4, as long as you have an odd multiple, like an odd number, times pi divided by 4, its reference angle is going to be pi over 4, right? Because, again, it all comes down to the x-axis, right? This could be 0. I could call this 2 pi. I could call it 4 pi. I could call it 6 pi, whatever, right? It's all about completing the rotations. This is over here pi. It could be 3 pi. It could be 5 pi. It could be 7 pi, whatever. But they're all 1 pi away from getting to that nice, even, whole number. That's why I always end up with these odd numerators, multiplying the pi, getting divided by the 4. That's pretty much it. All right. So now let's get through the pi over 3s. And then we'll talk about the nice, easy pi over 2s. Okay. So pi over 3 has pi over 3, reflect that. That one goes here. This one goes over here. So it's pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. All right, that's pi over 3. This will be the 2 pi over 3. This will be the 4 pi over 3. This would be the 5 pi over 3 right there. Right, first, second, third, fourth quadrant. So for this one, let's look at what's not included within the range. Within the interval of 0 to 2 pi. Right, we don't have 0 pi over 3. We don't have 3 pi over 3, and we didn't include 6 pi over 3. But everything else was included, and here's why. Well, 0 pi over 3, that's just 0. That corresponds to another reference angle. Pi over 3, well, that's just pi. That corresponds to another reference angle. 6 pi over 3, that corresponds to 2 pi. That corresponds to a different reference angle. So as long as you don't have a multiple of 3 in your in your numerator, multiple of 3, technically a multiple of 3. As long as you see a pi over 3 and you don't have a multiple of 3 in your numerator, it will have a reference angle of pi over 3. 1 is not a multiple of 3, that's reference angle. 2 is not a multiple of 3, that's reference angle. 4, not a multiple of 3, that's reference angle. 5 is not a multiple of 3, that's reference angle. That's pretty much it. Right? And here's why, and again, that's why we don't use the multiples of 3, because we get something else when we simplify the fraction. All right? So now, as I promised, the pi's over 2. So pi over 2 would be this angle of rotation. I start here and I rotate this way, so that's 90 degrees off. I start here and I rotate there, that's also 90 degrees off. So between 0 and pi over 2, I have pi over 2 and I have 3 pi over 2. Okay, but notice the ones that I didn't use again. I didn't use 0 pi over 2. I did not use 2 pi over 2. And I did not use 4 pi over 2. That reduces to 0. That reduces to pi. That reduces to 2 pi. Those are different reference angles. As long as I have an odd number in my numerator, multiplying a pi, dividing by a 2, it will have a reference angle of pi over 2. So that's what I look for. Odd number over 2 with the pi next to it, reference angle pi over 2. Don't even think about it twice. Because the other alternatives would be these answers over here, which I've shown will get you different reference angles. Hope it helps.